Alright guys, today's goal, the learner will understand how to evaluate and graph polynomial functions. Okay, so polynomial functions are based on their degree. If degree is 0, f of x equals a constant, so f of x equals negative 14. That's just an example. F of x equals 2, 3, 7, negative 12, doesn't matter. When the degree is 1, the polynomial is linear. Standard form, another way that you can think about this that we've seen that you should be more familiar with, mx plus b. Any line. Okay? A quadratic, that's what we've been dealing with all of first chapter. Degree is 2, there's an example. Degree of 3 is cubic, degree of 4 is quartic, so those are just different ones. And if it keeps going up, you don't have to call it a specific type, you just call it a polynomial if there's higher than a degree of 4. You don't have to, you say 5th degree, you don't have to call it quartic. Okay? Decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. Okay. So, in order to be a polynomial function, it has to have a degree of greater an integer greater than 1. A degree of greater than or equal to 0. So, is this a polynomial function? Yes. To write it, you have to write highest degree to lowest. So we took care of the standard form, state its degree. The degree equals 1. State its type, linear. And leading coefficient. Well, leading coefficient is the number attached to the highest degree. Well, the highest degree is 1, so the lead coefficient equals negative 2. Okay? So I look at number 2, I see x to the 4th, so that means it would be, but negative 2, watch. If I write this correctly, that would mean this. When x is negative 2, it moves it down. That is no longer a polynomial because the variable is in the denominator. So, not a polynomial. So yes, this one is h of x equals 6x squared minus 3x plus pi. Pi is a constant. The degree is 2. The type is quadratic. And the lead coefficient, 6. So that's what a polynomial is, okay? Use direct substitution to evaluate the polynomial function for the given value of x. What that means? They're telling you f is negative 2. Substitute it in. That's why it's called direct substitution there. Okay? So, go ahead and calculate that. (16 plus 12 minus 7, 5. Double check, that was just quick mental math. If I made a mistake, let me know. So go ahead and press pause and do the second one. So you get g of 4 equals 4 to the third minus 5 times 4 squared plus 6 times 4 plus 1. 64 minus, let's see, 16 times 5, 80 plus 24 plus 1. 64 minus 80 plus 24 plus 1. 9. Okay? End behavior. The end behavior of function's graph is the behavior of the graph as x approaches positive infinity or negative infinity. For graphs of a polynomial function, the end behavior is determined by the function's degree and the sign of its lead coefficient. Okay, so when the degree is odd and the lead coefficient is positive, every time it's going to be negative. As x goes to negatives, follow me there. What's y doing? Going to negative. As x goes to positive, goes to positive. Now, if it's odd and the lead coefficient is negative, it switches. When x goes negative, y goes to positive. When x goes to positive, y goes to negative. If it's an even degree and the lead coefficient is positive, they're both positive. If it's an even degree and the lead coefficient is negative, they're both negative. That's just going to happen every time. Okay? So it says use synthetic substitution to evaluate the polynomial function for the given value of f. So we did direct substitution. Now synthetic. Watch what I do here. They're telling me x equals 2, but watch. I copy down 5, 3, 1, negative 1, 7. You just always bring the first number down. And then what you do, 5 times 2 is 10. And then you add it down. What's 3 plus 10? 13. 13 times 2, 26, minus 1. Negative 1 plus 26 is 25. 25 times 2 is 50. Add this, so 57. So that is your final answer, 57. There's synthetic substitution. So let's look at that again, but let's be careful here. See how the degree is 4? That means you're supposed to have a column of 4, 3, 2, 1, 0. So watch what happens. What's the fourth degree coefficient? Negative 2, negative 1. Do we have an x squared? No, so you got to fill in with a 0. 4, negative 5. You always bring the first one down. What's negative 2 times negative 1? 2. Negative 1 plus 2, 1. 1 times negative 1, negative 1. 1, 5. Negative 5, so you get negative 10. There's your final answer. So there's synthetic substitution. We're going to be learning something called synthetic division at some point, so we need to understand this setup process. Okay, so graph the polynomial function. This is what you need to do. Make the table. And then calculate them. So, because I want accurate graphs, so you don't just use your calculator. So you do negative 2 to the fourth plus 6 times negative 2 minus 3. You get 1. Plug in negative 1. You get 4. Plug in 0, you get negative 3. Plug in 1. You get 4. Plug in 2. Oh wait, I feel like, hold on. I feel like that's wrong. Negative 2 to the fourth is 16. Plus 24 minus 3. That should have been 37. And then same thing here. Now plot those points and graph it. So that's what you need to do for all of those. Pick negative 2, negative 1, 0, 1, and 2, and graph them. Okay? So bring that completed tomorrow with the graphs. Alright. If the wind speed is measured in miles per hour, the model in example 6 becomes E equals that. Graph this model. What wind speed is needed to generate a wave with 2,000 foot-pounds of energy per square foot? So ask me tomorrow on the calculator to show you how to get these tables. Okay? But the other part, it's telling you it's 2,000 foot-pounds of energy per square foot. So the E is the energy. So how they want to know how much speed we're going to need. S to the fourth to watch what we do. 2,000 equals 0.051 S to the fourth. So go through and solve this. So 2,000 divided by 0.0051, you get S to the fourth equals 392,156.8627. You should never round till the very end. Well, how do you do this? You take the fourth root. Take the fourth root. So you get that it would take, well, we're going to have to round here, so instead of equals, you would say approximately 25 knots. Knots was the speed, okay? So there we go. Just remember to finish those graphs, and I'll see you guys tomorrow.